Through the Oracle PL SQL in 10 minutes. In this video we will cover chapters 11 and 12, which are aggregate functions and calling functions from within PL SQL. So if we look at data manipulation functions, we're looking at basic things like in the previous one we did a function called rtrim where we're trying to trim down a string. Well, there are other ways of doing this. So I can go in and do things like I want to manipulate text, I want to manipulate numbers or dates so that it's much easier to do operations on. And the example we're going to start with is if I want to convert things to uppercase, I can select the vendor's name and then return it all uppercase. It's a real simple one. So notice the Acme is now returned upper, and then the Anvil's R Us is upper, whereas previously it was lower. So we're taking the same value and just returning it slightly differently. So some of the things we can do are, I can trim, I can take everything to lowercase, I can look at the length of things. Soundex is kind of an interesting one in that it uses what I think is enunciation. So if we've got somebody stored in the database as y_lee and we don't know how it's stored, so our first question is, can I find a customer contact y.lee? Because I think that's what it is. I'm going to get an answer back saying it's not found. So there's nobody there like that. But if I can come in and say it sounds like y_lee, what I'd like to do is use the Soundex. And since we're using the English communication or English language set, that's what it will come in. So it will find a customer, someone like that, and we're going to see y_lee where it's L-E-E and there's no dot between no wildcard dot after the first name. So we actually went in and found something that sounds like it, which is a pretty powerful constraint. And it allows us to do a little bit more advanced manipulation of string searches. Now, as far as date and time, people like date and time in different formats. I can do things like extract years, months, dates. I can look at the last day of the month. I can look at the next day. I can look at today's date and convert a string to date. So any of these functions allow us to go in and pull stuff out. So the example of February 1st, 2015. And we come back with a customer ID and an order number that happened on that date. I can do multi-joins, as we did in previous chapters, where I'm looking for, it's either this date or another date. I'm looking for something that happened on February 1st or February 2nd, or between those two dates, and we get the exact same thing. So it gives us a range we can search from. And then a slightly different search that does something very similar, date related. Actually returns multiple values because we're within a date range of all of February. So if I wanted to say if I wanted to change this up a little bit, instead of saying the February 1st, I could say to the last date of February if I wanted to, and it would allow me to go in and do a variety of things. So rather than doing greater than or less than, we can use the between function as we saw earlier. And the between function basically just formats it a little bit differently, but returns the exact same values. Now here's an example of we are going to go in and pull out the year and the month, and we're looking for February 2015, whereas before we said between these dates, where here we're going to say extract the year from the order, and if it's 2015, and extract the month from the order, and it's February, then we come back with the exact same orders. So it's basically different ways of doing the same search, and whatever you're comfortable with is the way I'd recommend moving forward with. There are other functions I can go in with, things like absolute value, exponential values, sine values, tangent values. So, if I'm looking for more complex math manipulations, I can do that. So the next thing we're going to look at is summarizing data, which is kind of an extension of the math values. If I'm looking for the average value or the maximum value or the sum of things, say for example we're looking for the average price of products sold, we can just, instead of doing the complex calculations, we say just show me what the average is of product price for all the products. So it shows us an average. Notice how far out the numbers go. It does do a pretty high level of precision on the calculation, which might or might not be the right thing to do. And then if I want to do specifically for a single vendor, what's the average price for a specific vendor, I can come in and make that happen just by putting the where clause on there. And it comes back with a slightly different average. I can also do things like count, where I'm going to go in and select how many customers we have. And it comes back and shows that we have 5 customers. If we had multiples, we'd have to use the unique function. So what I'd like to do is insert that in there, and it'd give us a slightly different answer. So if I want to look at how many customer emails we have, this is actually going to go count the valid numbers, so the null values, because we have a couple customers that don't have email addresses. So this will go in and say, pull out all the customer emails and give me a count. Now, one of the beautiful things about this is for the Oracle database, these counts are being embedded into the chipset. So on the Spark chips and on the Solaris operating system, a lot of these functions are being embedded into the chips to make it perform a little bit faster. Not that big of a deal, but if I have a billion products, it does speed up a variety of things. So I can look at the max price, I can look at things like the min price. A variety of functions like that. I can look at sum for things, how many were ordered. I'm looking for a specific quantity of how many parts were ordered from of a specific product. Whereas I'm going in and looking at quantity of items ordered for a certain product, and that's order number 20,005, and it comes back and gives me the raw number of, we've got 19 of these ordered. Real easy if I'm going in and looking at inventory, that allows me to go in and look at it, and then I want to see, okay, so what's the price on what we're getting for this? So we're looking at the item price times the quantity, and that tells us what the average price is that we're getting for this service. So we can do aggregations, as we talked about earlier, where we say unique or distinct, so that I get specific values. And I'm going to say I'm looking for a distinct product price and then trying to find the average from the products for the specific vendor. If we got And I can go in and combine things. So, I'd like to look at the count of things, look at the min price, max price, and average price, which gives me a good reporting as to how well things are happening. And it allows me to report that fairly nicely in a good format. So I've got 14 items, min price $2.50, max price of $55 for an average price of $16.13. So hopefully this gives you a good concept of using stored procedures and stored values. This book doesn't really go in and talk about all of the functions and the variables and permutations. I'd recommend going to the Oracle document library for the 11 or 12 database. To be honest, this part of it doesn't change, so it doesn't matter which one you look at. But there are a ton of stored procedures, things like standard deviation and gradients and a variety of functions that I can go in and do on top of SimGoal